Hi guys. Okay, now look at this question very well. You might have seen this question. You're familiar with this question in the past question, right? Till tomorrow, some students don't even know why the answer is the answer you saw in the textbook or in your past question. Some students still don't know it. So imagine you come across this one instead of cramming. What if you now forgot? Because option C and option D look similar. What if you forgot and you want to pick option C? You get, look at the question. It says a simple pendulum of length L has a bulb of mass M. As the bulb moves from position P to position Q, from position P to position Q, the bulb, no simple pendulum now, to and fro, good. As the bulb moves from position P to position Q, the work done against gravity is what? This is very, very cheap question. And look at what? Normally, when the body moves, when the body is going upward, it's moving against gravity. Okay, and since they say work done against, it's actually the energy it uses, because when we say energy is the ability to do, so the ability to overcome gravity, that's the work done. So work done against gravity is actually a potential energy, because energy that deals with height is potential energy. So it's very, very easy. So the work done against gravity, let me call it W. Work done against is simply mgh. That's the work done against gravity. But then, if you look at this, of all of these options, there's not like it. They don't even give us h, but it's very, very easy. Now look at it. I'll redraw this diagram. So this is it. The bulb. Now this bulb here, this is the bulb. This is the length of the thread that is only holding the bulb. Let me call it L. That's the L. I hope you know that when this bulb displays to this side, it's still the same length that will be there, L. The only difference is that at first the bulb was vertical. That same bulb with the same length moves to this side. It's the same length. So the length here is still the same length. It's just like this. So look at it. Okay, look at this marker now. This is the height of the marker. If I twist this marker like this, does it mean that the height of the marker will change? No, it still remains the same. If the height of this marker was initially 2, if I twist like it still remains 2. If I put like it still remains 2. But anyhow I done, the marker height still remains 2. Or when as you had your height now, if you lie down, your height will reduce. No, exactly. So the bulb here like this, the whole length of this bulb is the same thing here. The only difference is that the bulb was raised through a particular height. So as the bulb moved from this point P to this point Q here, it was working because gravity is acting now. So it was working against gravity to reach this point. So the person is asking, what is the work done against the gravity? So this bulb actually moved through a particular height. So let me just do something like this. I'll make it an easy labeling like this. So this from this point here to this point here, that's the height the bulb has moved through. Are you with me? Then from this point, this is theta. Then from this point O here to this point here, let's call it Y. I hope you know that from here to here is the length, but here to here is the height it has moved. Then from here to here, I want to call it Y to make our thing easy. So if from here to this place here is Y and here to here is H, then the total length is L. Then we can say Y plus H is equal to L. We are not lying. Yes. Are you following now? Good. So moving on, this is point O. This is, let me call this place point R, and let me call this place S. So that's a right angle triangle, ORS. So from triangle ORS, if I redraw that triangle ORS, I'll have something like this. I just remove this triangle out, right? So this place will be Y, this place will be L. Is that not it? Because our L remains the same. Are you following me now? Good. So this is theta. So let's go. What is the relationship between theta, Y, and L? So the relationship is that cos theta is equal to adjacent Y over hypotenuse L. Are you following me? So my Y, if I cross multiply, my Y is equal to L cos theta. As easy as that. But it's not what I'm looking for. What is the work done we're looking for? MGH. I'm looking for H. So I will come back. I'm coming back to this, my initial equation. If I make H subject to the formula, my H will be equal to L minus Y. Is that not it? What is my Y? See what I got for my Y here. My H will become L minus, what is Y? L cos theta. Is that not it? What is common between these two is L. So my H will be equal to L into bracket 1 minus cos theta. Are you following me now? H equals to L into bracket 1 minus cos theta. Now put this whole thing back into this formula here. We have work done is equal to mg. What is h? L into bracket 1 minus cos theta. mgl 1 minus cos theta. That's mgl 1 minus cos theta. That's how they got this opportunity. It's not actually difficult. You can see that it's very, very easy. Meanwhile, if you are a student preparing for JAMB 2027 or you are currently writing post-semi, we actually have a lot of programs for you, ranging from chemistry, medicine, physics series, JAMB classes, and so on. All you have to do is simply send a message to me on WhatsApp using this number 07036, that's 36593057. Just send a message to me on WhatsApp so that we can give you the full details of the class. I hope you learned something. Just share, follow, and like. Thank you so much.